Ever pondered the intricacy of the McGinty equation known as MEQ, or the grandeur of the theory of everything, also referred to as L_τ? Their complexity can indeed be intimidating, but with a clear breakdown and some simplification these concepts become far more accessible. First up, the McGinty equation. This equation is like a pond, with PSQFT_xt representing the undisturbed surface. This is the standard behavior of quantum particles, unperturbed by external influences. Then, there's ΨFractal, TDMQQS, the ripple in the pond, showing the effect of fractal structures on the quantum field. Think of it as the impact of a gust of wind on the water's surface. Now to the parameters of this equation. The fractal dimension d is a measure of how complicated the fractal structure is. Higher dimensions imply more intricate patterns. The parameters m and q stand for mass and charge, respectively, similar to weight and electrical attraction or repulsion in more familiar physical contexts. Then there's s, the scaling factor, acting as a zoom level, determining how the fractal pattern repeats across different scales. Moving on to the theory of everything, or L_τ. Start with a brief overview of the four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. These can be grounded in everyday experiences, like the magnetism holding your fridge magnets or the sun's energy, a product of nuclear forces. The L_τ is akin to a grand puzzle-solving endeavor, aiming to fit all these different forces into a single, coherent picture. The unification of these forces is significant as it holds the potential to solve long-standing mysteries in physics. The implications of understanding these forces better are immense, ranging from technological advancements to potential breakthroughs in our understanding of the universe. In summary, the complexity of concepts like the MEQ and L_τ can be unraveled by breaking them down into their base components and using relatable metaphors. The McGinty equation can be seen as a serene pond with ripples depicting the influence of fractal structures on quantum fields, while the theory of everything is a grand puzzle, aiming to fit together the fundamental forces of the universe. These simplified explanations aim to make these complex theories more accessible and less intimidating, opening up the world of theoretical physics to a wider audience.